All right, guys. So we are just starting a brief introduction of radicals, simplifying radicals to kick off our trigonometry and right triangles unit. So this may or may not be something you've seen in the past years. You've probably looked at it a little bit, but what we're going to do is look at how to simplify radicals. So this first chart here all has radicals that are perfect squares. So what a radical is basically saying what times what equals this number. So the number under the radical is saying what times what equals 1. So the only way to get to 1, something times itself, is 1 times 1. Square root of 4, what times itself equals 4? Square root of 9, what times itself equals 9? What times itself equals 16? 5 times 5 is 25. 6 times 6 is 36, and so on and so forth. So again, that's what a radical means. It's what times itself equals that number. So the square root of 121 is equivalent to 11. Square root of 144 is 12. So for perfect squares, those are very straightforward. If you have them memorized, that's great. You can always plug them into your calculator. Now the trick is, what if it is a non-perfect square? So these above were all called perfect squares. For a non-perfect square, we have to be a little more careful. So what I do is I take a non-perfect square, so the numbers below are all non-perfect squares. We want to split this up into two pieces. The largest perfect square we can find that fits into this number times the remaining factor. Okay? So let me show you how I do this, and you can try a couple on your own. For the number 32, I'm going to split this up into its largest perfect square. That's the key. So we have to do this by looking for the factors. It's not adding or subtracting into 32. It's multiplying into 32. So I don't want you to write this. Don't write this. It's not 25 and 7. So that would be addition. Addition doesn't work this way. It works differently when you're dealing with radicals. 25 plus 7 is 32. But the square root of 25 plus the square root of 7 is not 32. So when we're looking for these perfect factors, it's not addition or subtraction. It's the multiples that go into 32. So the largest common multiple that fits into 32, the largest perfect square, if you take your calculator out, we know that 32 divided by 25, that would be too big. So the next one down is 16. So if I do 32 divided by 16, there it is. That fits in evenly 2 times. So if I take this square root of 32 and I divide it into 16 times 2, the square root of 16 is just 4. And the square root of 2 we can't do anything else with. So the square root of 32 we can break down into 4 radical 2. And that's your final answer. So notice what I didn't do. If you thought about this, and I don't want you to write this again, we also could see that 8 and 4 can multiply to 32. So 4 is a good number to pick because 4 is also a perfect square. So I could break that 4 down to a 2. But we would have to go another step further and look for the greatest perfect square that goes into 8. So this is not the wrong way to do it. You could do it this way. But if you don't find the biggest perfect square that goes into this number, it's going to cause more steps in the future for you. So I would always recommend start with the biggest number you think of and work down from there. So the biggest perfect square that fit into 32 was 16 and 2. So let's try 500. 500. Looking up at my list of perfect squares, 149. We want to start with the biggest range of this. So I think this is one we can probably do on our head. We know that 500 can be split into 100 times 5, the square root of 100 times the square root of 5. And the reason I picked 100 is because it turns into just a plain old 10. It's not the square root of 10. It's not 10 times 10. The square root of 100 is just 10. The square root of 5 we can't do anything else with. So we can simplify the square root of 500 into 10 times 5. Sorry, 10 times the square root of 5. All right, so if you want to try a couple on your own, I'll probably do 2 or 3 more together. If you want to try letter C by yourself to see if you got the hang of it, try letter C now. But I am going to do it together just so you can see some more examples. Okay, so if you tried it on your own, you can pause and then unpause. I'll work through this now. So it's the square root of 24. There's a lot of multiples that go into 24. I could break it down into 12 and 2. I could break it down to 8 and 3. Those would all be mathematically correct. But the problem is none of these numbers I picked are perfect squares. So none of those help us. So again, when you're doing these simplifying radicals, you want to find numbers that are perfect squares. So if I look at the square root of 24, I know 24 is 4 times 6. And the reason I picked 4 is because that breaks down, that simplifies to just a plain old 2. That was the biggest perfect square. Okay, now if you look at the 6, yeah, I could break the 6 down more into 3 and 2, but 3 and 2 aren't perfect squares. So that doesn't do anything for us. It doesn't accomplish anything. All right, so that 6, yeah, it could be broken down further, but none of the numbers it breaks down to is a perfect square. So we're stuck here. The farthest we can go is 2 radical 6. All right, I think I'm going to do letter D and letter G now. So try those 2 on your own. We'll have a lot of time to practice this next class, but I wanted to introduce you to the skill. So if you're ready for it, go ahead and pause and try 108. And if you're not ready for it, I'll go through that now. So if you want to try it on your own, pause now. So 108, I don't want to start small. So it looks like I think 108 could be divided by 4. Yeah, it works. But that's not the biggest perfect square. I can go bigger than that. So maybe I'll try, I don't know, maybe I'll try 49. So that doesn't work. 49 doesn't go in evenly. Maybe I'll try the next number down. Maybe I'll try 36. So there we go. Now we're talking. 108 can be broken into the square root of 36 times the square root of 3. Now, the reason I picked 36 is because it breaks down to a plain old 6. I can't do anything else with the square root of 3. So the square root of 108 can be broken into 6 radical 3. All right. Letter G. Let's just keep this 3. Let's hold our thoughts on this one for a second. We'll keep that out of the picture. Let's just worry about the 45 for a second. So 45. All right. 36 is too big. 25 is too big to fit in evenly. 16, that won't fit. But how about 9? I think 9 should work. So 9 times 5 is 45. So now we have our perfect square. The square root of 9 is 3. The square root of 5, I can't do anything else with that. So I'm left with 3 times radical 5. Now, the only last question is, what do we do with this 3 out front? Remember what's really happening here. This is like saying 3 times radical 45. It's not 3 plus radical 45. It's 3 times radical 45. So if you think about it that way, what we really have is 3 times 3 times radical 5. So 3 times 3, that's where I can get my 9 from. 3 times 3 is 9. And then I'm left with the radical 5 that we can't do anything else with. All right, guys, so we'll do a couple more of these for our warm-ups. We'll extend it to some more challenging. We'll do some multiplying and dividing of fractions, but that's it for our short video. I don't think there's going to be a 4-point homework check next class, but don't hold me to that. I would be ready for it, but I'm probably not going to give it to you. So I'm sorry, that's kind of not a great answer, but just watch the video, make sure you're ready. Otherwise, you're going to be lost at the beginning of class and you'll not know what to do. But come see me if you have questions, and I'll see you next time. Bye.